Hello Math Nerds, this is video 6 of the Unit Circle series. So today's big question is, what is a radian and how does it relate to the unit circle? Alright, so a radian is a way to measure the outside of the circle. And what we're going to want to do, and pardon my rough sketch of the unit circle, but this is really kind of what most unit circles look like, kind of rough. So just kind of go with me on this. What we're going to need to do is we're going to need to know the length of this arc, this opposite of 30. And we're going to relate 30 degrees to that radian measure, and we're going to use them interchangeably. So we've got to figure out how to measure around the outside of the circle. The reason this is so important is because I can actually take a tape measure and measure this and give you like a certain length, and you really can't measure an angle with a measuring tape or anything that is measurable. So I need to have something that relates to 30, and the arc out here does. So let's talk about the whole circle, and then we'll talk about the small parts of the circle. So how do you find the distance around a circle? Well, I think that's called circumference. And so circumference is equal to 2 pi, and you can't see me writing, so sorry about that, 2 pi r. Boy, if we only knew the radius of this unit circle. But we do. So the circumference is 2 pi times 1, which is simply just 2 pi. So if you start over here at 0, and again this is still 0 in radians, this is like where you start, so that's your initial 0, and you go all the way around this circle, that length is 2 pi. And pi is about 3.141596, So if you think about that, that's a little over 6 somehow. 6.28, something like that. So if the whole thing around is 2 pi, and I need to divide the circle up, I'm going to start like I did with the quadrantals. I'm going to find out how much the quadrantals are. So if the whole thing is 2 pi, then if I go halfway around, this is 1 pi. And then halfway in between there would be pi halves. So the distance from here to here is pi halves. If you add another pi halves, you get to pi. If you add another pi halves, then you get to, now we'll move this up a little bit, then you get to 3 pi halves, or 1.5 pi. And then if you keep going, you get to 2 pi. Just like with the degrees where we do 0 and 360, we also do 0 and 2 pi. So that is the distance around the outside of this circle with radius 1. Okay, so how do we find out how much this little arc is across from 30? Well, how much of a circle is 30? So I'm going to come up here and do a little figuring. So 30 out of 360, how much of the circle is it? Well, that goes out, and I think that's 1/12. So it's 1/12 of the circle. So if the whole circle is 2 pi, then I need 1/12 of that to be across from 30. So 1/12, I'm getting close to my circle here, 1/12 times 2 pi is equal to pi over 6. So this length is pi over 6. That's what that length is. So pi over 6 and 30 will be used to talk about that section of the unit circle. So if we go through and kind of do that for the rest of them, how much is 45 degrees? Well, I'm going to do the 45 degree, and this is kind of hard. I'm going to start writing on top of each other. It's okay. So now I'm talking about that whole part. So how many 45s are there in a circle? Well, we could do this the easy way or the hard way. We could do the algebra, and I don't mind doing that. But look, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them. There's 8 45s in a circle. So I guess I could have done that with the 30s. It's just a little harder to do with the 45s. All right, let's say you don't like that. Let's just do the algebra way. Well, I'll do this over here so you can see it. So 45 is how much of 360? And then that, see, that doesn't cancel nice or anything. But I think does 9 go into both of those? I think so. And that's 5, and 9 goes in that 40. Oh, that'll go one more time, and that 5 goes into both of those, an eighth. So see, it is 45 is an eighth of the circle because there's 8 groups of 45 all the way around the circle. So I need an eighth of 2 pi, and if you cancel the 2 and the 8, you get pi fourths. So now I'm looking at this whole section right here all the way to there, and that is pi fourths. And then if I do the same kind of process with 60, because from here all the way to there is 60 degrees, all the way to there. Maybe another color pen would work or something. Let me see if I can find one. Or maybe even a highlighter. That would be nice. Okay, so from here to here is 60. So that means from here all the way to here is what we're trying to find. What is that? How much of the circle is that? So if I want to do the same math, which I can, we'll come over here, I think you can see this, then I say that 60 is how much of 360. This is nice, that cancels, right? You get 1/6. So what is 1/6 of 2 pi? Well, that 2 and 6 cancel and give you pi thirds. Okay? So the blue arc is, I know what I'm going to do. I'm going to write it and highlight in blue with that. So all of that is pi thirds. I don't know where I'm going to write this. I didn't plan for that well, did I? So the arc from here to here is pi thirds. Okay? All right. So let's go label our unit circle with these, and then we'll go from there. It's underneath my tablet. So let's look at it. There it is. Yay, the good old unit circle. We love it. All right, I'm going to have to move back a little bit so you can see it all. Okay. There we go. All right, so let's fill in what we know. And so these little marks right here are for the radian measures. So we know that this is pi 6 because that is how much of the circle it is if you measured it, right? This one is pi fourths and this one is pi thirds. Okay? All right. So now we have to figure out the other measures. And so I'm going to kind of take the approach that I did with the angles. If this is pi, figured that out, right? Then if I go a pi 6 backwards, see, from here to here is pi 6, that measurement. So from here back would be pi 6. So if you have a pi and you subtract a pi 6, you get a 5 pi 6. I know, right? And if you have a pi and you subtract a pi fourths, you get a 3 pi fourths. And if you have pi and you subtract pi thirds, you get a 2 pi thirds. Okay? So that's really cool. We love that a lot. And then if you take pi and you add, let's see what I'm adding, that's pi 6. So if I add pi 6, so some of you have problems with fractions. So for those of you who have a hard time with fractions, I'm just going to spend just a second to kind of let you think about this real easily. If you have pi and you subtract pi 6, that's like saying 6 over 6, right? I changed that to the magic 1. So 6 minus 1 is 5 pi 6. Okay? If you have pi and you want to add a pi 6, Change that to 6 over 6. 6 plus 1 is 7 pi over 6. See how I did that? So I changed that pi to something with the same denominator, then I can just add numerators. So if that helps anybody with that fraction. We have people that don't like fractions, but you can't be scared of fractions. They're your friends. So that's 7 pi over 6. We have pi plus 45 is represented by pi fourths. So if you add, so I'm going to say it like this. 4 pi over 4 plus 1 pi over 4 is 5 pi over 4. See how I just changed that to, I made the magic one right there a 4 over 4 instead of a 6 over 6 because that's the one I need to change to. And then pi plus, I'm going pi thirds because that's the same distance. So pi plus pi thirds, so I'm going to write this down so you can see my thinking. For my people who struggle with fractions, you're either going to like this or not, but it might help you. So if I have pi plus pi thirds, my magic one, I don't make it a 6 anymore. I make it a 3 because I need the same denominator, right? So 3 plus 1 is 4 pi thirds. That might help us in a minute too. So that's 4 pi thirds. I'm going to try to manage my space better that time. That 4 got underneath the bar. This is 3 pi halves, or 1.5 pi. Alright, so now what am I going to do? Lordy. Why don't we come and go backwards from 2 pi? Because that's kind of the thought process that we're going to talk about in a little bit. So if you have 2 pi, oh, there's a place for that. I didn't see that. Ah, there's a place for my 2 pi. I didn't know that. Okay. If you take 2 pi and you subtract pi 6, what would that look like? Alright, so let's think about that. I'm going to come back and show you my little algebra. So if I have 2 pi and I want to subtract pi 6, then if I multiply the top and bottom by 6, that is 12 pi over 6 minus pi 6. And if you do that, you have a common denominator, right? And that means that you have 11 pi 6. Because if you multiply 6 times 2, you get 12. And you're 1 pi 6 away from that. So 1 pi 6 away from 12 pi 6 is 11 pi 6. That's the way I think about that. So this is 11 pi 6. This is 2 pi minus pi fourths. So if you double 4, that would be 8. So in fourths, if you're thinking about this in terms of fourths, this would be 8 pi over 4. That's the same thing as 2 pi. So, okay, for my people who don't like fractions, I'm going to help you with this one too. So, if you want to talk about 2 pi in terms of fourths, you got to say 8 pi over 4 because that reduces to 2 pi. That's the same thing as 2 pi because I'm trying to do this. Okay, so that's the same thing, but I have to have it in terms of 4 so I can subtract it. So 8 pi fourths minus pi fourths is 7 pi fourths. So if you double your denominator and subtract 1, you get your length. If you double your denominator and subtract 1, you get your length. So that is 7 pi over 4. And so I know this is going to be a third somehow because it relates to this triangle up here, right? So I know it's a third. So let's see if I can use what I learned. If I double 3, that's 6. If I subtract 1, that's 5. So it's 5 pi thirds because I'm back from 2 pi. See, I'm back from 2 pi. So that is how the circle is divided into radians. Now I want to show you a few tricks that are just so fun you're not going to believe this. Okay, you ready? Hold on to your socks. Okay, so this circle is so symmetrical. All of the triangles that go with 30, or the 30 triangle, and let me refresh your memory for those of you who did not remember. Remember that one, right? And now flip it over, and it's that one right there, right? So these two measurements have the same triangle that represents their lengths. And look, both of their radians have a denominator of 6. That's pretty cool. And then if I flip the if I flip it, that has, well, there it is. There he is. If I flip it, this guy has a 6. And if I flip it over, that guy has a 6. So all of the radian measures that deal with the 30-degree angle all have a denominator of 6. All of the triangles that deal with 45 degrees have a 4 in the denominator. There they all are. All have a 4. All have a 4. And then all of the links around the triangle that deal with a 60-degree angle, remember how we put that in there? The pi thirds, if you flip it over, oh, sorry. If you flip it over, I'm not doing very well. That's a third. Flip it down, that's a third. Flip it over, that's a third. So all of the triangles that deal with 30s end in a 6. All the ones that deal with 45 end in a 4. When I say end, have a denominator of 4. And all the ones that deal with 60 have a denominator of 3. One of the ways I help me remember that is that the 30 and 6 don't match. And the 60 and 3 don't match. And the 45 has a 4 in it. Don't ask me. That just helps me. And then all these numerators are 1 less than the denominator. Well, why is that? Because you're getting to 1. So, 2 is 1 less than 3. 3 is 1 less than 4. 5 is 1 less than 6. All of these numerators are 1 more than the denominator because you're just a little over 1. That's how we got it. We said 1 pi plus 1 fraction, right? And these all are, if you take your denominator and multiply it by 2 and subtract 1, you get that because we went to 2 pi and subtracted a section. So whatever makes that 2, which would be 12 minus 1 is 11. 2 times 4 minus 1 is 7. And 3 times 2 minus 1 is 5. Isn't that cool? I'm not done yet. Watch this. So if you think of the numerator as having a number 1 in front of the pi, and you take that number plus the denominator and sum them, then that would be 1 plus 4. And if you follow that line all the way down, that is the numerator. See, there's the 4 of the 3 that's straight across from it. So let's do that with pi fourths. 1 plus 4 is 5. Follow that line all the way down. There's your 5 in the numerator. Isn't that cool? I know, one of the kids showed me this. 1 plus 6 is 7. Follow that line all the way across. There's your 7. So the lines that go across have the same denominator because that's how the triangles are made. And if you want to find out what their number is, you can add the numerator and denominator. Let's see if it works over here in second quadrant. So let's see if it works. 2 plus 3 is 5. Follow that line all the way down. I'm crossing lines. And look, there's your 5 thirds. So same denominator, but if you add the numerator and denominator in the first and second quadrant and follow it down to the opposite quadrant, that's the numerator for it. Does this work? I don't know. Maybe I'm just fibbing. So 3 and 4 is 7. So I'm going to take this line and follow it all the way down. And look, there's the 7 in the numerator. Isn't that cool? And again, 5 and 6 is 11. Follow that down, and there's your 11 in your numerator. So all of the people across the unit circle from each other, and in that line that connects them, has the same denominator. And there's a way to figure out their numerator. I know, isn't that crazy? I told you I'd blow your mind on this one. All right, so that's all about radians, and we'll connect the dots in the next video.